Just to make, this is part two of looking at differences in proportions and how a distribution would look, and using some analytical methods here, some formula methods here to analyze these. You know, if for some reason we wanted to think about how many foreign-born residents there are in states in the United States, we can compare Alabama to Arizona. It's a good example is to show you there are clearly two different categories, two different states, two different denominators. And those percentages are different, you know, number of people born outside the U.S. So we'll just start off just getting used to using this formula on here. And again, that you can think of, you know, this set here, this set of numbers here is coming from Alabama. Maybe this set's coming from Arizona. That's where those two numbers come from. Now, just to make it a little simpler for putting the numbers in here, I rounded this one off to 14%. I'm going to round that off to 3%. So that's one of the calculations you're going to do. Your sample size is the individual sample size. In this case, there's 500 people from Arizona that were surveyed, and there were also 500 from Alabama. Now, just to clarify, this is the same number, but they are totally different groups of people. These are Arizona residents, the other ones are Alabama residents. So even though that number is the same, and it can be the same, occasionally it will be, they are coming from two different groups, two different sample sizes, two different sample sets. So you do your order of operations here, do your order of operations here, you add those decimals together. It's kind of a pain in the butt with a calculator, but you're going to have to add those tiny decimals together. And the decimal usually gets a little bit bigger when you take the square root of it. Again, these numbers are going to be tiny because these are percentage points. I think if you do all these calculations, hopefully you did. If you didn't, try it and pause the video. See if you get the same thing I get. Hopefully I did it right. I got between 1 and 2%, so 0.017 approximately. You could be a little bit higher or lower if you use these more accurate, tenths of a percent up here. It doesn't make a dramatic difference in how we're doing the calculations on here. Just want you to understand the process of it. So that would give me a standard error if I had this curve to look at, how spread out this data would be. Now, there's a couple other questions, if you haven't read them in here. Talk about the shape. Well, if the sample size is big enough, they should be normally distributed. The mean, and when we say the mean, we're really talking about the center of the distribution. Think about where this would be centered. And hopefully you realize we're talking about a difference between Alabama and Arizona. So the difference between these two would be the center of that distribution. This is about 10%. If you use the rounded values, it's more like 11%. It's around 10.5%. So if I were to look at this curve, and it does say somewhere here to sketch the curve, that would be the center of the curve, around 10%, 11%. And the standard error left and right would give you the idea of how spread out your curve is. Other piece of this is the shape. It's going to be a normally distributed curve. There's no reason to think that it wouldn't be unless the sample size wasn't large enough. So we've got to do that little deal where we check out if NP is greater than or equal to 10, and if n times 1 minus p is greater than or equal to 10. And unfortunately, you're not going to like this, you got to show that twice. You got to show it once for Alabama, make sure they're good, and once for Arizona. And it's not a hard calculation to do. N is 500 for both of them. P is just your proportions used here, these two numbers. And then do it again for these two. And you do have to check both of them. Essentially what we're just checking is, do we have more than 10 people that were, 10 people in each category as we break it all down. If I did this in a two-way table, every little cell in the table would have to have at least 10 people. So there's around 70 here and around 430. We're totally good on the sample size. From Arizona, check the same exact thing. For Alabama, we get pretty small here because of this small percentage. There are only 17 people from Alabama, but that's greater than or equal to 10, so we're good. We're not worried about the sample size being too small. So both of these met the criterion, should be normally distributed. The difference should be normally distributed. In terms of sketching the curve, we know the middle is going to be that original difference. And we know if we go 2 standard deviations this way, in other words, 3.5% roughly, and 3.5% that way, we'll get this normally distributed curve. Hopefully that makes sense. There's like the 95% confidence interval kind of shown on there, which eventually we'll do in the next section. I would say don't try to do this one on your own, simply because part B is an important question. Not yet. Don't do it on your own yet. So part A, you're writing confidence intervals. Should we use the formulas for a single proportion or difference proportions? Read through this Coke Pepsi problem real quick. And think about part A. So hopefully it makes sense that this is a single proportion. This is just one proportion we're looking at. It's the same group of people, which it looks like if I add that number and that number, I think I get 500 people again. There's 500 samples on here. Yeah, 500 people. I'm just looking at the Coke group versus the Pepsi groups. It's the same proportion. This is not a new formula thing. So now, good time to pause the video and try to see if you can do parts B and C and do a little hypothesis test review for yourself. I'll be back in part 3 to reveal some answers on there of a hypothesis test. Go for it.